Okay, so today what we're going to talk about is the triangle angle sum theorem and the exterior angle theorem. The way this works is it's just to keep in mind first how we can find missing angles in a triangle. Sometimes we're going to use the other angles that are inside the triangle, and sometimes we can use the angles that are on the outside of the triangle. All right, so what I'm going to show you guys real quick is why it works, okay? All the interior angles of a triangle do add up to 180 degrees. I'm in caps lock. All right, so I'm going to pull up a Delta Math. I did find where they have the preview so I can have a student account. So if we look here in this line, triangle IJK is drawn. You can say IJK. Now the line LIM right here, this bottom line here, is parallel to segment JK, which is this top line here. Okay? Does everyone see that? Good. So what we're going to do is we're going to look here at these fill-ins. So it says the measure of IJK is equal to one of these other angle measures. So if we look here, IJK is this 49-degree angle right here. And so because JK, this line here, and ML, this line down here, are parallel, angle KJI and JIL are congruent because they're alternate interior angles. Okay, that's going to be a huge thing. We're going to see that a lot. Alternate interior angles. So see how they took the angle we were looking at, flipped it around, and it filled in perfectly. Okay, so now we're going to look at the other side. If we look at these parallel lines, and we see that this side is a transversal, we know that KIM right here, this angle in here, is congruent to JKI because they are alternate interior angles. Okay? Now you may be wondering, why is this so important? Because most of the rest of our units depend on the fact that the interior angles of a triangle are 180 degrees. All right, so the measure of angle JIL, which is this 49-degree angle here, and the measure of angle KIM plus the X in the middle are going to equal 180 degrees because they form a straight line. So if I add 49 and 69 and subtract from 180, what do I get? So I'll take 180 minus the sum of 49 and 69, and I get 62. So X here is 62. And if you notice, it wants me to move the vertices around, that's the corners. No matter what I do, those angles stay the same. They're not the same angle measures, but notice how they're always forming a straight line no matter what. All right? So this is the proof for interior angles equaling 180 degrees. A proof is a mathematical process in which we can actually demonstrate that something is true. Not all mathematical concepts can be proved because there's an infinite number of numbers. All right? But this is one of the ones that we can prove to be true fairly easily. So moving on to the exterior angle theorem. So if we look at this image here, the exterior angle, outside angle, is angle 1. But it's not just any angle that's outside the triangle. It has to be formed by extending one of the sides. Okay? It cannot be formed simply by drawing a line. It has to be from extending one of the sides. So we can see here that this side length continues outward. Okay? If we look back at our example here, this angle that's formed with line JK and segment IJ, this angle right here, this is an exterior angle for this triangle. However, this one down here is not, because it is not one of the sides of the triangle extended. Okay? It's just coming off from a vertex off in a direction. So whenever we have an exterior angle, we can add up the remote interiors. Those are the interior angles that don't touch it, and that will give us the answer that we're looking for. So in this case, the measure of angle 1 is equal to the measure of angle 2 and the measure of angle 3. We add them together. All right, so now we're going to do a couple of examples. So we're going to look at number 1. Number 1 is fairly easy. They give us 2 interior angles and ask us to find the third. So in order to do that, we need to remember that we're going to have angle 1, measure of angle 1, added to the 24-degree angle and the 37-degree angle is going to equal 180 degrees. So that tells me the measure of angle 1 is equal to 180 minus the sum of the other two angles. And if I'm using Desmos, I can highlight, copy, and paste the expression that I want to evaluate. And we get 119 degrees. All right. All right, looking at number 2. Again, we can see here that if we wanted to find this angle right here, and we already knew angle 1, so let's say we wanted this angle here, but let's say, and we already knew angle 1, we would just subtract it from 180. It's the same thing. We're going to take these two, we would subtract them from 180. That's why they can add up. So for this one, the measure of angle 1 is equal to the measure of the remote exterior or interior angles. Remote means not adjacent. Usually you will use your remote to control your TV from across the room, and we get 128 degrees, okay? Number 3, we're going the opposite way. We are given the exterior angle and asked to find the second interior angle, the remote interior angle. So if to find the interior angle I add, in order to find the exterior angle, I'm going to subtract. So we can say that the measure of angle 1 plus 79 degrees is equal to 104 degrees. Therefore, the measure of angle 1 is equal to 104 minus 79. And when we run that through a calculator, we get 25. So the measure of angle 1 is 25 degrees. All right, we're going to look at number 4 here. 4 looks a little bit more complicated, but I promise it's not. We already have enough information to get angle number 1 and angle number 3. Okay? And that's because we are given these two interior angles, the 84 and 66. So that's how we would find angle 1. Or if we took 180 and subtract 84, that would give us angle 3. So even without knowing the exterior angle theorem for this one, you would be able to solve simply because you know that interior angles of a triangle add up to 180. So what I'm going to do is I'm going to go ahead and find angle 1. So the measure of angle 1 added to 66 and 84 is equal to 180. So the measure of angle 1 can be found by taking 180 and subtracting the sum of 66 and 84. Normally we would combine like terms before doing that, but in this instance it's better to see what we're subtracting, not just the total. And we get 30 degrees for angle 1. So now we are going to do angle 3, because first we need to do angle 3 before we can do angle 2, or we can do angle 2 by using the exterior angle. So let's actually go ahead and do angle 2. So the measure of angle 2 plus 43 degrees equals 84 degrees, which means that the measure of angle 2 equal to 84 minus 43, 41. And finally, for angle 3, we can either add up the 41 and 43 and subtract from 180, or we can just know that 43 plus 41 is 84, and just take 180 minus 84, which is our exterior angle. So the measure of angle 3 plus 84 equals 180, which means that the measure of angle 3 is equal to 180 minus 84, gives us 90. Okay, so on this one, the first thing I did was I actually forgot to delete all this information, so that's okay. For the measure of angle 1, what we did was we realized that the measure of angle 1 plus 61 plus 68 is equal to 180 because they are the interior angles of the triangle. So the measure of angle 1 is equal to 180 minus the sum of 61 and 68. And if you are using Desmos, you might be able to do it using the Google calculator as well. Desmos is better. You get 51 degrees. Okay, so that's how we got 51. For angle 2, anytime two lines cross, they create vertical angles, and vertical angles are always congruent. So we didn't have to do anything with angle 2. We just had to know that it's across an intersection from another angle, and therefore is congruent. Now, the reason here I have that angle 3 plus angle 2 equals 90 is because we know that this is a right triangle because of this box right here. And anytime you have a right triangle, you know the other two angles have to add up to 90 because one of the angles is 90. So when we took 90 and subtracted 61, we get 29. All right, so for number 9, the given information is that line L and line M are parallel. So we actually don't have to do all the math here on every single one of them. We have to acknowledge we have to use our knowledge. So we see that line L and line M are parallel. So I'm going to trace them in one color like I always do when I have parallel lines. I want a thicker line than that. Okay, so line L and line M are parallel. And then our triangle is made up of the transversals. Okay, so what that tells us is that angle 4 and the 49-degree angle here are congruent because they are alternate interior angles. So I'm going to put 49 degrees because, and I'm just going to put a note, alternate, okay? So they're alternate interior angles. We can see the same thing on the other side of the triangle here. You can see the 73-degree angle here and angle 1 are also alternate interior angles. So angle 1 is 73 degrees. Oh, degree wrong. And again, it's alternate interior angles. So now we have enough information, easy enough to do 2, 3, and 4. Or 2, 3, and 5, sorry. I personally would want to do 5 first because it's easy. It's a linear pair with angle 4. So it is 180 minus the 49 degrees. And that gives us 131. 131. And you can just put a note if you want, linear pair. We can do the same thing with angle 3. 180 minus 73. Again, that's a linear pair, which gives us a measure of 107 degrees. And then finally, angle 2, we can either say is angle 5 minus 73, or we can say it's 180 minus the sum of the other two. I'm going to say it's the measure of angle 5, which is 131, minus the 73, because that's our exterior angle theorem. That's one of the things we're meant to be practicing, so it's a good idea to do. So we have 131 minus 73. That gives us 58 degrees, and that's our x. Okay. So that is, those are the problems I wanted to cover today. Okay. We will go over some of these algebra problems as well, but these are going to be a little bit, they're going to be pretty simple. They're just solved for x. So I will fill these in. You'll have no problems really understanding them because it's, again, just add all these angles up, equal 180. Add all of these up, equal 180. Add these two together and it equals this one. Okay. Add these two, it equals this one. They'll be there. So what I would recommend is when you have a moment, review them and, review them and make sure you look over them before we test on this in like however many weeks, like 2 or 3 weeks. Okay. So that's all we have for right now. You guys can work on whatever you need to.